Exercise 10C question number 1. Find the acceleration when particle of mass 400 is acted on by resultant force 120. So basically this is a particle and this is 400 kg and 120 Newton for act. So we will put F equal ma to this direction. So 120 equal 400 times a. So we need to find the acceleration. So a equal, rewrite this one, 400 a equal 120, a equal 120 divided by 400, 0.3 ms minus 2. Question 2. Find the weight in a Newton of a particle of a mass 4g. Basically, F equal ma. So particle weight that is 4 kg. So F equal ma to downward. So m is 400. Sorry, 4 kg. 4 times a is 9.8. So this is going to be 39.2 Newton downward. So this force is called weight. So basically W equal mg. So this F is especially called W, weight. So W equal mg, then 4 times 9.8, simply you can work out 39.2. So this is the equation for it. But you can stay with this one. W equal mg, 4 times 9.8, that is 39.2 Newton. Question number 3. An object is moving on the rough surface experience. Assume this is the object. So this is moving to this direction. And there is no force, but there is a friction. For example, if you push this one and initially I give a force, then after that there is no force, then because of friction it stopped. So likewise, so this one is moving and the first phase is rough. As a result, there is a 30 Newton force, frictional force, and this direction is moving, and weight is, let's take m, and deceleration is given a is -2, 1.2, it's a deceleration minus. So when f equal ma, we'll put to this direction or any direction we can put. So this is going to be -30 because it is in this direction. M times a is -1.2, it's a deceleration. Hence 30 equal 1 times m, because minus cancel out, m equal 30 divided by 1.2. That is going to be 25 kg. Question number 4. Astronaut weight 735 on Earth and 120 in the moon. So this is Earth, moon, W equal mg, W equal mg. So this on Earth 735 equal m times 9.8. So this is 120 times m times a. We don't know, we need to find a. So a is the gravity in the moon, acceleration in the moon. 1 divided by 2, 735 over 120. Actually will divide 2 divided by 1 because 2 divided by 1, 120 over 735 equal m times a over uh, m times 9.8. M to m cancel out. A equal 920 times 9.8 over 735. So we put the same equation to moon and the earth. So this is for earth. This is the Newton, and this is the same mass, but due to the acceleration differences, we have 735 here. 120 mean definitely A should be less than 9.8. This is 1.6 ms minus 2. Without division, you can make m as a subject and substitute here, and you can find a. This is another way, but this for me this is easy, I feel. Question number 5. This is 2 kg. This is P and 2g Newton, and this is accelerate 3 ms minus 2. We want to find this system is going upward. P has to be more than, because it has acceleration into this direction. We need to find P. So F equal ma, we have to put upward or downward. You can put any direction, but I will put upward because it is the moving direction. So force is this side force, P is there, then negative 2g equal m times, m is, we know that now, m is 2, and acceleration is 3. So m equal 2 kg, a equal 3 ms 2 to this direction. So P equal 2g plus 6. So 2g mean 9.8 plus 6. So this is going to be 25.6 Newton upward. This system part B, this is 4 kg. So this is system is accelerating downward. We'll put F equal ma to downward because it is downward acceleration. I can see 3 forces, 1, 2, and 3. So for this direction, 4g minus plus 10. 10 also it is in this direction. Mine, this is opposite P, equal m is 4 times a is given 2. So this is going to be 4 times 9.8 plus 10 minus P equal 8. So P equal 4 times 9.8 plus 10 minus 8. That is 41 Newton. F equal ma to downward, question number 6. This whole setup is accelerating downward. We need to find the mass. So F equal ma to downward. So this is positive mg minus this is negative times m times a is 5. So this is 9.8 m minus 10 equal 5 m. So 9.8 minus 5 m equal 10. 4 point m equal 10. M equal 10 divided by 4.8. So m equal 2.083, so approximately 2.1 kg. F equal ma to upward. So because this is part B, the acceleration is 2 ma to upward. So this is positive upward one. This is negative mg equal m times 2. So 29.8 m. So g is 9.8. This is 2m. So 20 equal 9.m plus 2m, that is 11.8 m 20. So m equal 20 divided by 11.8. This is equal to 1.69, and let's say 1.7 approximately kilogram. Question number 7, we need to find the acceleration. This is 2 kg, and this is 2g, and the force is 8 Newton, and there's acceleration to this a. So F equal ma will put downward. So 2g minus 8. This is the other force upward times m times a. M also we know now it is 2a. So 2a equal 2 times 9.8 minus 8. So a equal 2 times 9.8 minus 8 divided by 2. So a equal 5.8 ms minus 2. So this is part B. So I'll put F equal ma to upward, because acceleration in this side not necessary, but uh, this is 100 Newton, so that is a positive one. 100 minus this is 8g equal 8 times a. So 8a equal 100 minus hg I right. So this is a equal 100 minus 8g divided by 8. So a equal 100 minus 8 times 9.8 divided by 8. So this value is 2.2, 2.7. Question number 8. Force of 10 Newton acting upon a particle with 3 kg. So this is 3 kg. Newton 10 is acting on in a rough horizontal plane. So this is horizontal plane. So this is 3g is the, and the normal reaction is R, and rough horizontal plane. So there is a frictional force. If say this face is rough, not smooth, then I will take this is as F. Now F equal ma to this direction, because this is only moving. It has acceleration 2 ms minus 2 horizontally, so we don't need to consider any force go vertically. So F equal only F equal ma is to this direction is enough. So this is 10 positive direction, then minus F equal m is 3 times a, we know now this acceleration 6. So 10 minus F equals 6. So F equal 10 minus 6, that is 4 Newton. So m equal 3 kg and a equal 2 ms minus 2, this direction, and the answer is 4 Newton. The friction force is 4. Question number 9. The lift mass 500 kg, lower raised by means by metal of a cable adjustment. So this is a lift. So it has attached to a cable, and this is 500 grams weight, and there are people, so that weight is 300 grams, or total is 500 plus 300, so I can represent as 800 gram. And part A, we need to find the acceleration. So it is given that it is start from rest, and then u equals 0, and it travel 5 meter, and then reach to 3 ms minus 1. So we need to find the acceleration. So we'll put to this direction. V square equal u square plus 2as. V square is 3 square equal u square is then 2 times a is a and s is 5. So 9 equal 10 a equal 9 divided by 10, 0 0.9 ms minus 2. So this is the acceleration uh, of the lift. And part B, the tension of the rope. The tension of the cable if the lift is moved vertically downwards. So tension, let's say T. If it is moving downward, we'll put F equal MA for that journey. Then F is going to be 800. Um, 800G, and minus T. M is 800 times A, we found out that is 0 0.9 to this direction. So T equal 800 grams, 800G minus 800 times 0 0.9. In 800 factorized, this is 9.8 minus 9. So 800 times 0.8. There's a bit of calculation error. So this is 800 times 9.8 minus 800 times 0 0.9. So this is, you will get 7120 Newton. Part C, the tension in the cable lift is moving vertically upward now. We'll consider upward journey now. F equal MA, we'll put upward. So this is going to be T, the tension. This is 100 grams again. M is 800 times A is going to be 0 0.9 upward now. So this is 0 0.9. So T equal 800G plus 800 times 0 0.9. 800 times 9.8 plus 800 times 0 0.9. So the answer is 8560 Newton. Question number 10. The trolley mass 50 kg pulled from the rest. U equals 0 ms minus 1. Along the horizon by means of a rope. So there's a rope attached to it. So after 2 seconds, So it will take the speed of 1, v equal 1 ms minus 1, and there is a frictional force that is 20 Newton resistant to the motion. And part A, we need to find the acceleration. So we can use v square equal u square plus, no, we can't do that. V equal u plus at to this direction. So v is 1, u is 0, plus a is we don't know, and t is 2. So a is half a, or 0.5 ms minus 2. The tension of the rope, which is T, which is pulling by part B, F equal MA when you put this direction, T minus 20 equal 50 times, 50 times A, we found out 0.5, 20 plus 25, 45 Newton. So the tension of the rope is 45 Newton. Question number 11. The engine of a van 400 kg cut out when it's moving. When it is moving to this direction with 16 ms minus 1. So the forces is stop, the engine is stop, and the van comes to a rest without brakes. Okay. So when it stop, it will become to a v equals 0, u equals 16. So without a brake, it is coming to a 0. It means there should be a restriction force to this direction. Let's see, it is mentioned applied in the model situation. Assume that the restrictive forces of, oh yeah, so this is 200 in restrictive forces. Now from here we can find the mass is given 400. We can find the acceleration of the journey. So F equal ma, when you put up this direction, this is a moving direction. So this is 200 Newton. This is the only force about, and mass is 400 times A we don't know. So A equal minus 200 over 400, which is minus 0.5 ms minus 2. So this is a deceleration. Deceleration is 0.5 ms minus 2. M equal 400 kg. And the next question is find how long it takes the van to stop. So question A, we want to find how long it will take to stop. So we have v equals 0, u equals 16, v equals 0, a we found out 0.5 negative, ms minus 2. So we'll put v equal u plus 80 to this direction. V is 0, this is 16 minus 0.5 plus minus 0.5 times t. T equal 16 divided by 0.9, that is going to be 16 divided by half, 16 multiplied by 2, 32 seconds. So next question is how far. So v square equal u square plus 2as. Then this direction, v is 0, u square is 16 square plus 2 times a is 0.5 times s. Then 0, 16 x square minus zero point 0.5 times 2 is 1. So minus s. So s equals 16 square, which is 256 meters. Part C. Comment on the suitability of the modeling assumption. Uh, we can tell that the restrictive 0.5 times 5